Hello everyone. So here we are back at the neck journey, and here's where the rubber meets the road and it all goes together. In previous episodes, we've seen the preparation of the bent veneer and the Douglas fir neck core. Normally, the veneer I use is matching the sides and back of the guitar. Not always, but nearly always. I think it's a nice look. Let's have a look at this one that's in the mold already. This is ready to be laid up, and we'll have a quick look at this, and then we'll go about preparing this one in a similar way, show you how this all works. We've taken, I think it would be 4 cuts on this part. They include cutting the part to length and fitting the end of the part up against this hard stop here at the end of the tool, the end of the neck mold, to locate the veneer in this direction. That's super important because we need the hole here where the veneer is to line up perfectly with the square hole in the neck tool. Can we look down in there? So we can see how the part and the tool are lining up. And then the other thing is we've cut down the excess height so that we have about 1/8 of an inch or 3 millimeter lip of veneer sticking out of the mold all over the place. And finally, we've cut a little notch out of the end of the veneer. The purpose of that is so that we get a nice joint between the veneer and the end grain surface of the headstock on the base side. This is a fitted surface. I take great care to get this exactly right so that this looks perfect when it all comes out at the end, so that there's a perfect butt joint between the end grain of the veneer and the end grain of the Douglas fir. And we could have a quick look at a finished guitar just so you can see how that works out. And here's the intersection that we're calling out now. So you can see it's a very nice invisible joint between the end grain of the veneer and the end grain of the softwood core of the neck. Okay? So that's our goal. Let's have a look at this veneer. I'll show you the steps that I just enumerated to get this thing to play nicely with the mold. So first thing is we're going to use our template here to mark the length of the neck veneer correctly. Should be somewhere here. See how we do with a handsaw here. Of course, there's a lot of ways to do this, but all right. This doesn't have to be perfect everywhere, but it does need to stop convincingly, especially in the center. So Well, let's see how we did. So these are the clamps that we're going to use to ultimately locate the veneer in the way I just had it. So these clamps have little steps on them to help hold the veneer and position it in this direction. Of course, part of that is to get the square hole to line up perfectly and get the veneer to be in the right place, all right? So we're going to take this guy and put it in here, see how we feel about this stop. I'm going to take a little bit off here. Okay, that looks fine. Sitting in the middle, that's what we want. Now we're going to use this guy. So this will help push the veneer down into the tool. So that we can mark it on the sides. I like it. Okay, I'm going to use this piece of steel, which is 1/8 of an inch or 3 millimeters thick. That'll allow me to get a mark here. Of course, the outside of this part that we're marking is covered with linen, as you may remember from our episode about making this crazy piece of veneer bent across the grain. All right. Got a good mark? We're going to go to the bandsaw. And cut this down to size. So I've used this little block here. There's a number of ways we could deal with this now. I could push it on a piece of sandpaper or plane it by hand. I'm going to go ahead and use a belt sander that I built for working on the neck in a variety of ways. And it just makes quick work of a thing like this. So an important feature of this machine is the foot switch, which controls the motor. And this is a wonderful idea that I got from my buddy TJ Thompson, in whose shop I saw it first years ago. Fantastic idea, super helpful for a thing like this where you get to put the work exactly where you want it, figure out how to press on it so that you can take the cut you want and then start the machine instead of lighting up the machine and then trying to somehow land the work on the moving surface. Anyway, much more control. Thanks, TJ. So this doesn't have to come out perfect, but it's nice to have a flat surface for the clamps to address when we're positioning the veneer in the fixture. So I've left just a little bit of the line. We're going to call that close enough. And we have a nice smooth surface for our clamps to address. So this is ready to go back in for the rest of the fitting. All right, this time we're going to use our clamps, individual clamps. That'll help us position the veneer exactly how we want it. I've been through three actually, iterations of this clamp over the years. I should mention that this original tool that you're looking at, although it's been modified and added to over the years, this tool I made in 2005, and all of the necks that I've built since then have come from this tool. And it's probably time for me to make another tool or two. I've got a couple of 7-string guitars to build, and while I could probably figure out how to sneak a 7-string neck out of this tool with a little modification, I think I'm going to bite the bullet and just go build a new tool. This time I think I'll avail myself of CNC technology. Back in 2005, I decided that, well, I was just too stubborn to get somebody to make it for me on a CNC machine. So I built this whole tool on my Bridgeport, and worked out great. Came out just about perfect. And it's been a useful tool ever since. It's the only way, I think, that you could hope to make a part like this, is to have a tool that'll take some heat. And let me explain that by telling you that epoxy resins that cure at room temperature are not particularly strong as epoxy resins go. If you need really high strength in a layup, and I found that I did need that in the neck. I needed better strength than I could get with the garden variety room curing epoxies that we're all familiar with and happy to use. So what I'm going to use for this layup now is an epoxy resin that requires quite a lot of heat to cure at all. It just won't ever cure at room temperature, I don't believe. In return for the bother of playing around with extra heat, you get incredibly good mechanical properties. So, in other words, the finished part comes out way, way stiffer, because as we know, composite material, in this case carbon fiber and epoxy, has two components, those that I just mentioned, the fiber and the epoxy resin. And each of those components contributes its attributes to the final composite structure. Anyway, long story short is that room temperature epoxies are too weak for this job. And so we're forced to use high temperature curing resins in order to get the mechanical properties that we need to make a perfect neck. So I'm going to make a quick mark here just for fun, because that's the end of the mold. Just keep track of that. Now, the next thing I'm going to do is I'm going to mark the hole, the square hole in the veneer, and then cut it precisely to line up with the tool. So that's why I've concentrated the clamps down here. I see up here the part is not twisted, it's doing fine, and I've got enough clamps on it right now, if I handle it carefully, that it should hold the veneer in place while I mark it for cutting. Of course, it wouldn't be good to damage the tool, the inside of the mold, with a scribe while you're marking it. So I made a special scribe that I use for nothing else, and it's just a simple tapered scribe that's polished everywhere, so that no matter how I manipulate it in there, it won't be able to make any damaging marks on the tool. Okay, so I've got the tool tipped up, and I'm gonna point my flashlight in here and scratch out from the corners. Okay, we're going to remove this now and mark the last part that we need to cut. So this will be the cut that addresses this surface on the neck core. Okay, so now we're going to go to the Bridgeport milling machine and pick up, that is locate, these scribe lines that we have, and then cut away this hole precisely with a milling machine cutter. So I'm just checking to make sure that the part is reasonably square and lined up with the tool. All right, that looks good. I'm going to use the digital readout and the center finder to locate the hole. So first, make sure the center is is located properly, and just eyeballing this line, and we'll set a 0 here, and then eyeball this other line. Which should be 875, but because of the scribe marking inside the hole, we see it's 860, but so that's okay. And now what we're going to do is divide that by 2. Let me press this button here and then tell it to divide 860 by 2. And then we do the same thing in the other axis. To locate the pocket in Y. Again, something less than 875. Again, we'll divide by 2. Okay. So now we know where the center of the pocket is. That would be 0, 0 on our milling machine readout. Then I put in a 1/8 diameter cutter. Sorry, you metric guys. It's about a 3mm cutter. I know these numbers don't make any sense to you. Can't help it. It's how I grew up. Please forgive me. I was ready when I was 12 years old to go metric, but the country didn't keep up with their promises. Anyway, so now we're going to go around and just cut a roughing cut to release the center. All right, get that out of there. And now we're going to go to our numbers, which is 375 all around. Okay, so that's our cut. The only thing, two little details left. Of course, I have to clean out the corners with a knife. And I'm also going to round this part of this edge here and this edge here, because there's going to be carbon fibers coming up through this hole and then laying some of them in this direction and some of them in that direction. So we want those to have a little bit of easement so they don't go over a super sharp corner. These sides aren't so important, but these two sides, we're going to round them a little bit with a knife in order to allow the fibers to follow a little bit of a less kinked, less sharp, abrupt transition as they bend 90 degrees or so to go which way in that. And then, of course, we'll go back to the bandsaw. Maybe you don't need to see me cut this, but I'm going to use the same setup and just cut this little chunk of material out. And then this will be ready to fit back in the mold, and it's ready to make a guitar neck. All right, so that's the veneer prep. And next we're going to move on to sticking it all together.